Now let us take a next section after a C point and see what will be happen. So next section, x1 at distance x from A. Now what happens? Let us draw the free body diagram for the same one. W by 2, and here it is W. This is my section. SF x1 is equal to, see, on the left side of the section x1 there are two forces are acting, W by 2 and W. If we will take our sign convention, section left upward is positive, so plus W by 2, and section left downward is treated as negative, minus W. This will give me minus W by 2. So after the point C, the variation of shear force is minus W by 2, means from C point, after C point I will take a section over here, or maybe over here, maybe over here, or at any point between C and B, the shear force comes to be minus W by 2. Means I will comment like this: near just about point C on the left side, shear force is plus W by 2. Just right side of point C, it is minus W by 2. So now let us plot this shear force variation in terms of shear force diagram. Given beam is of simply supported beam. It is a preliminary things that you have to plot a dotted lines below all the loads or below after all the important points. So what I did, reaction, after that I draw a dotted line. Load is there only single, it's not W by 2, sorry, it is W itself, dotted line, and the reaction, dotted line. The value of reaction is W by 2, it is W by 2. This line is known as the baseline. All the positive values shown above the baseline, all the negative values shown below the baseline. Now what we found out, see over here, if I will take a section between A and C, the shear force variations comes to be plus W by 2, just like RA. So the shear force variation is of, at this point is W by 2, and at any section between A and C it remains unchanged, and it is of plus W by 2. So this is my plus sign. Now let us take the another color chalk or pen. At C point W is there, because of that if we are taking a section x1 over here, we found out the shear force that x1 is minus W by 2. So at point C there is a sudden changes from plus W by 2 to minus W by 2, and between C and B once again minus W by 2 for all the points with the minus sign. This diagram is known as shear force diagram, SFD. Let us conclude something on that. Simply supported beam, reaction itself, the contribution of shear force at that particular point. Second comment, at a concentrated load or at a point load, shear force changes suddenly, abrupt changes in the shear force. You can visualize there is abrupt changes in the shear force. Third observation, if between 2-point load, because this reaction is nothing but a point load itself or a concentrated load. So between 2-point load, if there is no load, shear force variation is given by horizontal straight line. I will repeat these three terms once again. Reaction for a simply supported beam directly shows the shear force at that point, like W by 2, W by 2. Sign convention shows, if I will take a section over here, left upward plus sign, section over here, it is upward but right upward, and right upward is negative as per our sign convention. Second observation, at a point load, shear force variation shows by sudden changes. Third observation, between 2-point load, if there is no load, like over here, there is no load between these 2 points, then shear force variation is given by horizontal straight line. So this is our shear force diagram, which has been shown over here. Beam is given to us and the variation of shear force diagram will be plotted over here. How it will become has been explained over here. Next, let us go how to plot the variation of bending moment diagram. Given beam is of simply supported beam. Central point is W. Reactions are W by 2, W by 2. Now, this is my A point, C point and B point. Take a section between A and C. At distance x from A. So let us plot the free body diagram for the same. Distance x from A. This is W by 2. So what is bending moment? BM means bending moment at section XX is equal to. Yes. What is bending moment? Definition. Bending moment is defined as algebraic sum of the moment of the forces. Algebraic sum of the moment of the forces to the left of a section. So because we have taken the left of a section, only one force is acting on the left side. This left side force creates a moment over here, is nothing but RA, that is reaction into X. Now this creates a moment section left clockwise, treated as positive with our sign convention. What is RA? That is W by 2 into X. This is the moment developed at bending moment at XX section. Means if I will take X is equal to 0, then bending moment at which location? X is equal to 0, then bending moment at A. W by 2 into 0, it is 0. If I will take X is equal to L by 2, because next distance at C, L by 2, then bending moment at C is equal to W by 2 into L by 2 is equal to WL by 4. So we can visualize from this equation that bending moment changes linearly from A to C as there is no load between A and C. Let us be found out for the next section between C and B. Let us we take another section over here, named it called x1 x1. Let us we draw the free body diagram. x1 x1 at distance x, this is RA, this is W, and this distance is x minus L by 2. Therefore, if I will take to find out bending moment at x1 x1 is equal to RA into x, as it creates section left clockwise tilted as positive, minus W into x minus L by 2. Why minus? Section left anti-clockwise. So we having an equation, linear equation. Now let us we put the value x is equal to L by 2. My bending moment once again at C is equal to W by 2, that is RA, x is L by 2 minus W into L by 2 minus L by 2. This term is nullified, 0, and we achieve WL by 4. The same we achieved over here. So bending moment at C we achieved WL by 4. Now let us see found out bending moment at B by putting x is equal to L. If we put x is equal to L in this equation, bending moment at B is equal to W by 2, that is RA, x is L minus W into bracket L minus L by 2, and if you simplify, this gives us answer 0. Now let us we plot this variation of bending moment along the length of the beam. Given beam is of simply supported, acting point load at the center. Once again repeat, dotted line under all the loads, under all the important points. Draw a baseline, reaction W by 2, W by 2, loads are of W. So on the previous pages, if you visualize that bending moment at A is 0, bending moment at C is WL by 4. So 0, here this value, this ordinate is WL by 4, and the variation, just observe the equation, W by 2 into x. X is 0, value is 0, x is L by 2, it is WL by 4, linearly varying. So this is the linear equation, linearly varying. Now observe the next section, x1 x1. Here visualize that at C point it is once again WL by 4, while at B point, that is support at B, the value comes to be 0. So at B point, at support B, the values are 0, linearly variation is there with plus sign. Why plus sign? Because you obtain the plus WL by 4 at all the places. So this is our bending moment diagram. Let us we comment on this certain parts. First one, bending moment at supports of a simply supported beams are 0. First observation. Second observation, between 2 point load, if there is no load, between 2-point load, here reaction RA, here it is W, there is no load is there, the variation of bending moment is given by inclined straight line. The variation of bending moment is given by inclined straight line. So now from this problem we will able to draw BM diagram also. Please observe here. See this bending moment diagram. For a simply supported beam, this is the variation of bending moment diagram. This is the variation of shear force, variation of bending moment diagram. Let us see once again critical comments on this. Between 2-point load, if there is no load, the variation of shear force is given by horizontal straight line. At a point load, the variation of shear force changes abruptly or sudden change in the shear force. Here for bending moment diagram, between 2-point load, if there is no load, the variation of BMD is given by inclined straight line. And the value of BMD at the two supports of a simply supported beam is 0. Let us go for a next problem. Problem number 2. Find the shear force and bending moment diagram at any cross section of the beam. Given beam is of a simply supported beam. The beam one end is hinge, another end is roller, subjected to UDL W kilonewton per meter throughout the length of the beam L. The step number 1 is to find out the support reactions using the equilibrium conditions. As support A, hinge support, so there are two reactions, RAH and RAV. Using the first equilibrium condition, sigma H is equal to 0, definitely RAH is equal to 0, because there is no horizontal load is acting on this particular beam. Sigma V is equal to 0, summation of all the vertical forces acting on